there is a rod. It's having a length L, in small as y, area of cross section A. Let the temperature be theta 1 degree Celsius. I'll increase the temperature. What will happen to the rod? The rod will expand. So now how much length? L plus delta L. Will there be any stress in the rod? No, no stress in the rod. Any reason for that? Because it is at natural length, no? At what is the length? What is the, you can write this, what is L? Length of the rod at theta 1 degree Celsius. It's at natural length at theta 1 degree Celsius. What about the rod now? L plus delta L. It is the natural length of the rod at theta 2 degree Celsius. So when the rod is at natural length, no stress will come. Sir, we are not understanding. You take simple spring. If the spring is at natural length, will there be any spring force? If spring is at natural length, will there be any spring force in it? No spring force. If there's no force, no question of stress. Getting the logic? This one. So will there be any stress in the rod? No stress. In the rod. Similarly, here also, no stress in the rod. Getting the idea? Okay, now I will increase temperature, but I will not permit it to expand. Let's take the question here like this. So there's a rod. Length of the rod is L. In smaller c, temperature theta 1 degree Celsius. I will increase the temperature. So what the rod? It wants to expand, no? But do I permit it to expand? So here, let's assume that I'll increase the temperature. So what will happen to the rod? The rod actually wants to expand. Fine. So this is the length L. So here is what? The elongation. But what happened here? I will not permit it to expand at higher temperature. I'm trying to explain the concept. You have to really catch this. What is the length of the rod? Is L. What is the temperature? Theta 2 degrees Celsius. At theta 1 degrees Celsius, what was the length of the rod? L. At theta 2 degrees Celsius, so what do you expect the length of the rod? Should be more than L, no? And this will be elongation. So how much elongation here? Delta L by 2. Delta L by 2. But what we are doing, we are not permitting to expand. So how much shall I say, what is the state of rod? At theta 1, it's in natural length. Rod in natural length. So when the body is at natural length, so no stress will be there. Now I'll rise the temperature. What should be the length of the body? So no, this is a natural length. Okay, no stress. So definitely what you can write? No stress, no strain, therefore no strain and no stress. Similarly for same thing this also. What is the condition? We can write it as no strain and no stress. Okay, now come for this one. What should be the length of this rod? Should be L plus delta L, no? But how much it is compressed? By an amount delta L. So shall I say that it is being compressed? Who is compressing? Being compressed. Tell me who is compressing it? The walls will not permit. The wall will not permit it to expand. So it is being compressed here. How much it is being compressed? By an amount delta L. You have to understand the method here. Finish. You can do very things easily here. So it is being compressed. So therefore, what happened here now? It is being compressed. So shall I say, or being stressed. So I want that thermal stress here. That has to be calculated. So what is the change in temperature? Delta theta. Okay, let's come for this one. So delta L should be equal to L alpha delta theta. So what do you mean by thermal strain? Delta L by L should be equal to alpha delta theta. We know stress Young's modulus equal to stress by strain. So what is the strain? Alpha delta theta. So sigma equal to y alpha delta theta. This is called like a thermal stress. So what actually the rod wants to expand, but the wall will not permit. So how much of stress is generated? This much here. So y alpha delta theta. What do you mean by sigma? Sigma should be F by A. So therefore, what is further F is equal to sigma into A. What is sigma? Y alpha delta theta. Delta theta is change in temperature. Please, no rotation, nothing. Y alpha delta theta is change in delta theta is change in temperature. What is F? F is the force set up in the rod. So we will set a force on one side. The wall will exert force like this. In turn, what will happen? The rod will exert force on the wall. This force per unit area will become stress. If there were no walls, the rod will expand. It is at natural length. So when a body is at natural length, no stress will be there. So are you getting? No? So okay, now you can ask questions. Sir, you increase temperature. I'll decrease temperature. Tell me, if you decrease temperature, what should happen to length of the rod? Should become less than L. But the rod will not permit. The walls will not permit. Then what will happen? The rod is in what, like elongated state. Then the forces will be in opposite direction. So now if the rod is at natural length connected between two rigid walls, if we increase or decrease temperature, what will happen to stress in the rod? Will become non-zero because the wall will not permit it to be at its natural length. Able to understand the concept here, why the stress will come? So what you have to, in all such numericals, what you have to search, is it at its natural length? Based on that, what happened, we should decide here. So how much of energy is present in this? So the energy present, elastic potential energy is stored. So we know stress is square by 2y. Y alpha delta theta. So if you solve this further, you'll get the energy stored in the rod. Simplest thing, elastic potential is stored in the rod. So what is delta theta? Change in temperature. Tomorrow we'll take few more better examples. Let me go for one more idea related to this. Okay, this is called like a bimetallic strip.